Imagine a world where the sun, for many weeks of the year, does not rise at all. Darkness shrouds coniferous forests, the air is cold and humid, and the ground may be covered with snow. We associate this place today with wolves or reindeer, and yet over 70 million years ago, in the Cretaceous period, lived there dinosaurs. It sounds like a contradiction. For years, dinosaurs were imagined exclusively in the tropics, among palms, ferns, and sun. But discoveries by paleontologists changed this image. It turned out that dinosaurs were not only rulers of equatorial jungles, but also inhabitants of polar forests, where winter lasted months, and the sun disappeared behind the horizon. This discovery completely changed all our knowledge about their biology. In this episode, we will travel to the Arctic, Australia, and Antarctica from millions of years ago to meet extraordinary creatures that lived on the edge of the polar night. Before we meet the inhabitants of this unusual world, let us stop for a moment and look at Earth in the Cretaceous period. Continents were still drifting, and the global climate was warmer than currently. In the north, North America was bisected by the vast western interior seaway, which split it into two parts, Laramidia in the west and Appalachia in the east. In the south, Australia and Antarctica remained joined, forming a fragment of former supercontinent Gondwana. There were no great ice caps yet, quite like today, but polar conditions still posed a truly enormous challenge. The long winter night, lasting even for several months, meant absolutely no light and a limited availability of food sources. In summer, however, the long polar day brought with it almost constant sun and very rapid vegetation growth. Scientists today can estimate the temperatures of those times thanks to oxygen isotope analyses and fossilized plant studies. In the equatorial zone, the average temperature was somewhere around 30 to 35 degrees Celsius. At the middle geographical latitudes, such as in today's North America or Europe, it was typically about 20 to 25 degrees Celsius on average. In the polar zones, where our dinosaurs lived, in summer temperatures reached 10 degrees Celsius, and in winter, they could drop around zero. This means that the Arctic and Antarctica in the Cretaceous period were not icebound like today, but resembled cool, damp coniferous forests. Despite this, in winter, frosty nights prevailed there and snowfalls probably did occur. And precisely in such conditions, which for many modern reptiles would be deadly, dinosaurs were able to develop their populations. And since we now know what the realities were, let's look at their unusual inhabitants. First onto the stage step, hadrosaurs. Imagine a huge herd of powerful animals, whose very snouts resemble duckbills. These massive herbivorous giants, reaching even 12 meters in length and weighing several tons, move together in groups just like modern reindeer do. Their specialized jaws, equipped with hundreds of teeth arranged in batteries, allowed them to grind tough needles, twigs, and tree bark. In winter, when vegetation died back, they could keep themselves alive just with this. The most valuable proof of their presence are remains of young found up north. They are what reveal that hadrosaurs were not merely summer guests. They lived there, they reproduced, and they raised their offspring, right in the very heart of the polar night. But the hadrosaurs weren't alone. In places where great herbivorous herds appear, sooner or later predators must also surely appear. In the shadow of the great hadrosaurs lurked Troodon, a predator that did not impress with its size, but compensated with its cunning and senses. It measured about 2.5 meters in length, and its eyes were truly among the largest of all the dinosaurs. It was precisely they that gave it an advantage during the winter darkness. Imagine it as an owl of the Cretaceous period, silent, attentive, able to spot the slightest movement in gloom. Interestingly, some scientists suggest that individuals living in the north could have been even twice as large as those from the south. This is indicated by fossilized teeth, which in some findings are over 2 times larger than in previously known specimens. If these interpretations are correct, it would mean that Arctic Troodons were exceptionally adapted to harsh conditions, combining unusual eyesight with more powerful sizes. Its brain, proportionally even much larger than in most dinosaurs, suggests it could likely plan and adapt its various hunting strategies. Did it act alone or in groups? We do not know that for sure, but we can be certain it was a master in a world of eternal night. You ask, who could Troodon hunt among the Arctic forests? Its natural prey were the small, agile herbivorous ornithopods, which lived in the forest undergrowth and almost blended in with the background. They did not impress with size, but compensated with speed and cunning. They often grew up to about 2 meters in length, and their mass clearly depended on the species. The smallest polar forms weighed only a mere dozen to several dozen kilograms. Their long tails likely stabilized the body well during sudden sharp turns and fast sprints. It was precisely this role of small herbivores, which in large numbers fueled the food chain, that made them a key element of the polar ecosystem. Their large eyes indicate that they saw well in twilight, which was priceless in conditions of the long polar night. Some discoveries from Australia even suggest that they were able to dig burrows, hiding themselves underground during the greatest cold spells or when a predator was lurking nearby. But even in a world full of fast and vigilant animals, there had to be a group of defenders, heavily armed giants, who relied not on speed or stealth, but rather on strength and armor. And so we come to the last hero of this story, the ankylosaur, the icy tank of the Mesozoic. Imagine a massive dinosaur, which instead of fleeing, stood up to fight like an armored fortress. Its body was covered by bony plates and spikes, and its tail ended in a powerful club capable of crushing an attacker's leg. Although ankylosaurs looked very slow, their diet and resilience truly allowed them to survive even in the harshest conditions of the southern continent. They most probably fed on conifers and other tough local shrubs, and their huge, heavy bodies likely acted as natural heat stores, thanks to which they could still easily function in the cool, polar climate. It was this unique strategy that made them one of the most unusual inhabitants of the Cretaceous period forests. But how did scientists discover that dinosaurs really lived in such conditions, instead of just migrating? The answers lie in rocks, remains of young. This is the most important evidence. If dinosaurs appeared in the north only in summer, we would not find young there. And yet, numerous bones of hadrosaur chicks have been found. Bone histology. Microscopic studies revealed lines of arrested growth, similar to tree rings. They show that dinosaurs experienced periods of slowed metabolism, most probably in winter. Oxygen isotopes, chemical traces in the bones, reveal the temperatures in which the animals lived. They indicate coolness, but not an Arctic void. Fossilized plants, conifers, ferns, and seeds in the Arctic rocks prove that lush forests existed there. Each of these proofs is a puzzle piece, which shows that dinosaurs really could live in a land of cold and darkness. Of course, paleontologists do not always agree. Some claim that hadrosaurs could have migrated, just like modern reindeer. Others point to the evidence of residency, the young and the lack of long migration traces. It is similar with their physiology. Were they warm-blooded like birds and mammals, or cold-blooded like modern reptiles? Life in the Arctic suggests that at least some of them had the ability to maintain body heat. Some scientists even suggest that small herbivores, such as hypsilophodonts, might have had feathery coverings protecting against cold. This is still a hypothesis, but increasingly, there are voices that feathers were not the domain only of predators. To better imagine this world, let us look at modern animals. Hadrosaurs resemble reindeer. Both species lived in herds, moving themselves through the polar forests. Just as reindeer used the summer to gather up energy, so too hadrosaurs took advantage of the abundance of plants. Troodon was like a snowy owl. Large eyes and excellent vision in darkness allowed it to hunt at night. Hypsilophodonts played the role of Cretaceous rabbits. Small, fast, hiding in burrows, they were the food base for the predators. Ankylosaurs resembled musk oxen. Armored, massive, and resistant to the cold, they were the natural fortresses of the polar world. Thanks to these comparisons, we can better understand how diverse and full of life the Arctic Cretaceous ecosystem was. Dinosaurs of ice and snow truly show us that these animals were indeed far more resilient and versatile than we ever previously thought. They could survive not only in the tropics, but also in the land of winter and polar night. And now a question for you. Which of modern animals most remind you of these prehistoric creatures? Write in comments.